So that says the integral of x times sine x dx. Let's use our standard approach. Is it one of the easy ones? Is it like x to the n or sine x? Okay, so you might make a mistake here. You might go, oh, it's got a sine x. That's easy. I'll just integrate the first bit as x to the second. No, you can't do that. Whoa. It's two things multiplied together. You can't. It's not a simple one. You've got to use a more complicated approach. Is it on the formula sheet? We can look on the formula sheet. We won't see it. I mean, well, it depends on which exam board you're doing, all that kind of stuff, but generally no. If it is, then go for it. Is it something divided by something else? Meaning it's a log? No. Okay, well that means it must be substitution or parts. Now, if it's substitution, we want something inside something else. So initially it doesn't look like substitution. Is it a parts? Parts usually is if we want to get rid of something. Oh, wait a sec. If we could get rid of that x, I can definitely integrate sine x. This looks promising. How would I get rid of the x? So we've got to use parts. I quite like to just write out the parts equation at this point. So the integral of u. Now you might have this written slightly differently on your formula sheet, but this is how I've got it written down. So maybe you're not using u's and v's, or maybe you might be using functions or something. Anyway, that's how I've got it on mine. So we want x to be differentiated. So we definitely want x to be u. We want that to be v. Okay. I like to do this little box. Let's get a shift on now. So u equals x. V equals dv dx. Did you spot my deliberate mistake there? So let's just correct that. So that should say dv dx is sine x, which means that du dx equals 1. That's great. That's made that disappear. Just put my box around here. I've got little boxes for everything, and what it does is it means that if I'm doing parts and I haven't got a box with 4 spaces in it, I know I'm doing something wrong. I'll just kind of get used to the look of it. Right, so I'm going to integrate that and find out what v is. So v is minus cos x. So now I can just use the formula. This formula here. I'm not going to go through this too carefully. Just keep pausing if you need to look where everything comes from. The u is x. The v is minus cos x. Then I put a minus sign. Then I put an integral. The v is minus cos x. The du dx is 1. And then I write dx. Horribly running out of room, so let's go on to the next page. So that's minus x cos x plus the integral of cos x dx. Let's just double check we've copied that correctly. So this is good exam technique here, by the way. If you're doing exams, always double checking you've copied things. That looks great. I'll just keep rewriting this, because I always like to have an equal sign, so I just keep writing. I'm writing the same thing, it just keeps being rewritten differently and with maths done to it. So the integral of cos will be sine, so that's plus sine x, and stick a plus c on the end. You might have been tempted to start sticking plus c's in earlier when we did an earlier integration. We don't do that with this method, it's not how it's done. Yeah, that's kind of it really.